Right, so we're going to talk about functions, and this is going to be, it looks like a ton of notes, but it's really not as bad as it looks, okay? So the first thing that we're going to talk about is a relation, and it says, what is a relation? And all it is a set of ordered pairs. And an ordered pair is just a coordinate. So like this. Okay. Somebody else got a pencil in their notes? We're good. Okay. Just a day. Huh? No, it's been good. I'm saying a day I don't have pencils. They're the ones that don't bring pencils. All right, so there are three ways that a relation can be represented, and we're going to talk about all three of them. And the first one is a table. The second one is a mapping, and that's probably the one you're the least familiar with, but we'll go over it. It's super easy. And then a graph. So you guys know what a table is. We've looked at our tables. We've looked at graphs. Okay. In Math 1, you start talking about domain and range. And in Math 1, domain and range is very simple. It builds on itself later on. So this is really simple. Domain is all the X values in the relation listed from the least to the greatest. And we'll go over every bit of these. This is just definitions to start with. So if you don't understand it right now, it's okay. All right. The range is the same thing except for its Y values. So all the Y values in the relation listed least to greatest. So then we're going to talk about, I'm not moving on yet. I'm just talking while you guys write. We're going to talk about how to do a graph, a mapping, domain and range, and a table. The easiest one is going to be the table, and then it should be graphing. You guys should know how to graph points. It's not any kind of lines or anything like, it's literally just graphing the points, okay? So that's what we're going to do first. So I'm going to start with the table first because it's the easiest. Remember with our coordinates, we have X, Y coordinates. So -2 is your X and 4 is your Y. You write that just like that in the table. -2 is your X, 4 is your Y. Your next one, you have XY coordinates. We have a 2 and a 5. It doesn't get any harder than that, guys, okay? What's my next coordinate? So we write a -3 and a -2. The next one is a 3, 3. Then we have 4, 2, and 5, -1. That's all you do for your table. Okay. If you have to make it yourself, which you will, if you have to make it yourself, you just make it like this and list it. -2, 4, 2, 5, -3, negative. It don't have to be pretty. Okay. It don't have to be pretty, just as long as you have them separated. All right. So then as a graph, I'm just going to graph these coordinates. So remember when we graph -2, 4, we start at 0, 0. It's always left or right first, then up or down. Okay. So this says on the X, we're going to go to -2. So here's your X axis, -2, and then up 4. The next one is 2, 5. So we're going to go to +2 and up 5. Do not connect those dots. We're not trying to connect them, okay? We're just putting dots on paper. We're doing -3, -2. So -3 is to the left and down. So left 3, down 2. The next one is +3, +3. So right 3, up 3. Again, remember to go left or right first and then up or down. We go 4, 2. So to the right 4, up 2. And then the last one is 5, -1. 5 and down 1. All right. Any questions on the mapping, not the mapping, the table or the graph? They're really easy, right? Everything you should already know. Got it? All right, so then for domain and range, that's probably new. Remember we said the domain was all the x's, and what's good is the table lists all of those x's. So we're only looking at this side of the table, but we want to write at least to greatest. So what's our smallest number in this column? -3. So you make these little curly brackets. If you can't make them, you can just make a squiggly line, and that's okay. All right. So a curly bracket, we're going to start with -3, and then we write a comma. So as you use them, I'm going to highlight them. You don't have to. I'm just highlighting you so you don't look at them anymore. Look at that x again. We've already used -3. What's the next smallest? -2. So we use that one. What's your next smallest? And then keep going. And when you get to the very end and you've used all of them, that's it. Put that curly bracket. Yep. And again, sometimes mine look more like squiggly lines than they do curly brackets, and that's okay. We're not trying to be perfect here. We're just trying to get the point across. All right. Same thing for range, except for we're going to use the Y. So again, remember domain is X, range is Y. You do the same thing, little curly brackets. See, that one looks like a squiggly line. It's not very pretty. What's your littlest one in this column? -2. So we got that. What's your next one? And then keep going. 2, 3, 4, 5. And then we've used them. That's it. So that's domain and range. It's really simple. List your coordinates, just your x's for domain, least to greatest. So the biggest thing people miss is listing least to greatest. Okay. It's not that they don't know the difference between x and y. It's that they don't list them least to greatest. Okay. Any questions on the first page? All right, flip it over. Now they give us a table and they tell us to do all the same things, except for we're going to write an ordered pair. Ordered pair is listing the points with parentheses. Okay, so I'm going to start with that. Ordered pairs is just your coordinates. And remember, our coordinate is x, comma, y in parentheses. Okay, so real easy. As you read your table, your coordinate is on the left and right side. So there's your coordinate right there. So your first ordered pair is -5, 3. That's it. What's our next coordinate? We keep going down the table. Our next coordinate is 2, 1. Yeah, okay. Your next coordinate is 3, -4. And your last coordinate is 0, 2. We're going to graph these. To graph -5, 3, remember we go left or right first. Since it's negative, we're going to go left 5, 1, 2, 3, 4, 5, and up 3 because it's positive. Again, left, right first. So -2, 0, we're going to go over to the left -2, and it says don't go up any. So we're just going to stay right there on the x-axis. The next one is +2, 1. So we're going to go to the right 2 and up 1. 3, -4, right 3, down 4. And the last one is 0, 2. Do not go left or right, just go up 2. So this is what your graph should look like. Do not connect the points. Right. Domain and range. Remember your domain are your x's. Make sure you go least to greatest, and your y's are your range. So these values in the x column in yellow are your domain. And in your y column is your range. Okay. Least to greatest. So look at the yellow. What's your least amount in the yellow? -5. What's your next one? -2. Keep going. And then 3. That's it. Same thing for the range. Remember, least to greatest. What's your littlest pink? -4. Perfect. What's your next one? Good. And if you guys have a repeat number, you don't have to write it twice. So like if we would have had another coordinate that was like 0, 2, 1, 2. So if we finish with 1, 2, the 2 doesn't have to be written twice. Okay, you can just write it once. If you write it twice, I won't count off. I'm just telling you that you may not see that on a multiple choice test. All right. So there are methods to determine if the points that we're given are a function or not. Are a function. That means one depends on the other. So the first way is a table. We don't want any repeat x's. So no repeat x's. If they repeat, it is not a function. So that's the key. We don't want any repeat x's at all. So we're going to look in the x column. We don't care about the y column. It doesn't matter to us at all. So I'm going to just mark it out so you're not even looking at it. And I want you to tell me if there are any numbers repeated in that yellow highlight. Yes, ones are repeated. So this is not a function. Right below it, I'll give you an example of a function. This is a new one. If you look at your x column, again, we don't have to worry about our y's. We just look at our x's. No repeats. So this one is a function. Okay, no repeat x's. All right, so we haven't talked about a mapping yet, but here's what a mapping looks like. You're going to have these two circles. At some point, you have probably seen this, but not really worked with it, okay? So we're going to work with it just a little bit, and then we're going to forget about it. This is the only time that you will use mapping in this class is for this set of notes and this test, and then you're done, okay? I know it sounds weird, but we're done. All right, so each x only has one arrow coming from it. Now, this is not, the mapping is not complete. I'm going to show you what I'm talking about. Again, each x only has one arrow coming from it. So I'm going to show you a function. These are your x values and these are your y values. Just like your table, you would list them. They do not have to be in order. They can if you want them to be. But you can see that these are not in order. Then you will see arrows Those arrows tell you the coordinates. So this would be the coordinate 3, 0. This would be the coordinate -2, 1. Okay, so it tells you coordinates. Notice how 3 only has one arrow going to 0, and -2 only has one arrow going to 1. That means that this is a function. Below it, I'm going to give you an example of not a function. I'm going to use the same numbers, 3 and -2, 1 and 0, so that you can see the actual difference. If 3 was graphed to 1 and 0, and -2 is graphed to 1. Okay, so you can barely see that arrow, I'm sorry. So your coordinates would be 3, 1, 3, 0, and -2, 0. I mean, -2, 1. Sorry about that, y'all. If you look at our x's, we have 2 3s. We can't have repeat x's. So what you're looking for is this right here. If more than one arrow comes from a number on the x1, then it's not a function. And we'll look at more examples. That one's the weirdest one. Okay, not a function. Then the last one is if you have a graph, and they don't really teach the vertical line test anymore. They don't really like that. They like it more like this, but this is super easy, okay? We don't want repeat x's. So no vertical line can touch 2 points. As long as it's touching 1, it's okay. And you can make as many vertical lines as you want on here. It doesn't matter. So let me explain what it doesn't look like, and then I'll explain what it does look like, okay? So I'm going to use my highlighter. If I make a vertical line right here, how many points did it go through? That's okay. We're good with that, okay? If I make a vertical line here, how many points did it go through? Just that one, right? Just that one. That's okay. This one's on a different line. If I make it over here, then it goes through. Still going through 1. However, if I make it on this line right here, how many points did it go through? This is not a function. Not a function because it goes through 2 points. The other ones were good. As long as we're good, that minute that we're wrong, it's not a function, okay? Any questions on that one? And we'll do a couple, just all definitions right now. We'll do a bunch of different examples. All right, check out your next page. We're going to determine whether it's a function or not. This means absolutely nothing. It's just left over from the other side. So you can mark that out as nothing. All right, so the question is yes or no. This is exactly what your test is going to look like. You're going to get either a mapping, a table, a graph, or that's it. Mapping, table, graph, ordered pairs. You can get ordered pairs. And you're just going to yes or no. 2 choices. Is that a function or not? So remember, when we're doing a mapping, we're looking for arrows. There's 1 arrow with 5, 1 with 3, 1 with 2, and 1 with -5. So I'm going to say there's no double arrows. Again, on your homework test, whatever, you don't have to write that. So this is a function. Look at your other mapping number 3. Look at your other mapping number 3. How many arrows are coming out of 3? 2. Remember, we cannot have that. So this is not a function. So the minute it's wrong is the minute you put no. All right, let's look at our 2 tables and then we'll check out our graphs, okay? 2 tables. Remember, no repeat x's. No repeat x's for your table. You're going to look at all of your x's. We don't care about y's. Just our x's. Do you see any that are repeated over 2?
One.
1, you are correct. So this one is not a function. On 4, 5, and 6, we're just going to write yes or no. We're going to look at 5, the table first. We don't care about our y's. We're going to look at our x's. Are there any repeat x's? So this is a function. Again, why? There are no repeated x's. And that's the key in all of these, okay? All right, so then remember with our graphs, we have to do the vertical line test. You can put your vertical line anywhere. What I like to do is get like a Post-it note or a note card or something like that and move it across my paper. And as long as I'm only touching one part of the graph, and if you guys look, I'm only touching one part of the graph. It's not touching one here and one there, okay? We're just gonna keep going. So this one actually is a function. Let me explain what a not function looks like. When I put my Post-it note over here, it touches right here, it touches right here, it touches right here, right here, right here, right. That's too many. So this one is not a function because it touches too many. Okay. This one over here, it only touches the graph right here. It only touches the graph right here. It only touches here. So no matter where I move this Post-it note, it's only touching one point. So this one is a function. Okay. This one is a function. All right. So then these last ones are usually, let me make sure I'm talking about what I'm supposed to be talking about. Yep, usually the ones that people have trouble with. So function notation is just a fancy way to write y equals, so don't freak out about that. And I'll explain why they write it as f of x. It's a function of x. To distinguish between different functions, they may use different letters. So you might see an f of x, you might see a g of x. And then a lot of times, especially when we get the quadratics, you'll see h of t. H will represent height and t will represent time. So height as a function of time. And we'll get there. We'll get there. Okay, so it's just a fancy way of writing that. So if I give you f of x equals 2x plus 3, that's the same thing as y equals 2x plus 3. There's nothing any different about that, okay? So when we get to graphing in our next unit, f of x and y are the same thing. Okay, so if it says f of x equals and you want to put it in y equals in your calculator, it will work. All right, that's all on this page. Let's flip through. We're not doing this right here. We're going to drop down to using the graph. You will have questions like this on your final exam. It is state exam. You have to take it. So it's pretty easy. So what it says is, what is f of 2? Now remember, we had f of x. And now we have f of negative 2. What did that negative 2 take the place of? We had f of x. What did negative 2 take the place of? X, right? Not a hard question, serious question. So this means that x is negative 2. So when we're looking at our graph, remember this is our x-axis. Negative 2 is right here. So all I'm doing, I'm going to slide it over so I can use my Post-it note, is looking at what is the point on the graph that touches negative 2. So this coordinate, if you guys can see, this is 10 and 20. So just so you can see it, this is 20 and this is 10. What is this coordinate right here? It is negative 2, 10. So when x is negative 2, y is 10, which means that that equals 10. So it's asking, what is on the graph when x is negative 2? So look at the next one. It's asking f of 0. So it's asking, what is y when you're on 0 at x? Okay. You guys see that? Open points don't count. I don't like this graph on here, so whoever put these notes together, I don't like them for doing that. We don't do open points in here, so we're not worried about that one. We're looking at this one. This coordinate is 0, 10. So what is y when x is 0? 10. All you're doing is looking for the y coordinate. They give you the x, you tell me the y. The next one is 1. There's your coordinate on 1. When I graph this, it's 1, 0. So when x is 1, what is y? That's it. That's all you do. That's probably the most confusing one on here, but we will keep doing those. Okay, throughout the semester, we will keep doing those. All right. It's easier when they actually give you the function. Okay. So all this says for the function is plug in 2. So you're going to take that 2 and put it in for any x that you see. If there's 5 x's in there, you're going to put it in for every single x, okay? So we're going to rewrite our function. But now I'm going to plug in 2. And I put it in parentheses just in case I have a negative, like on the next one. And then you guys can just use your calculators. 5 minus 2 is 3. That's all you do. Plug in, put it in your calculator. So on example 2, you're going to take that negative 3 and put it in for that x. So again, I like to rewrite the function. And then I plug in that negative 3 inside of parentheses. I like to do it inside of parentheses. When you get your calculator, type it in just like you see it. 9 plus 6 parentheses negative 3. Close it. And we get negative 9. Literally all you do, use that calculator. But every time you plug in, put parentheses around whatever you're plugging in. Okay. Any questions? Example 1 and 2. We're going to do it again. It's our last part. All right, so I'm going to do all the numbers first. If you guys look like on part B of this one, it gives you a lot. We'll talk about that in a minute. I want to do all the numbers first, and then we'll go back and do those variables. All right. So let's start with the first one. These are 2 different examples. So we're going to start with the first one. What does this one tell you? Plug in 4. So we're going to have 2x plus 3. And I told you to plug in 4 with parentheses. And then put it in your calculator just like you said. 2 parentheses 4, close it, plus 3. Gives us 11. That's your first one. What does the second one tell us to plug in? A 0. So I'm going to put that in there. So again, I'm using 2x plus 3, but it says plug in 0 for that x. And then I'm going to put it in my calculator. 2 times 0 is 0, plus 3 is 3. For the ones that are really easy like this, you don't have to use your calculator, but I would check it. Just like I've been telling you before, just check it to make sure that in your head you did it right. I make mistakes too, and I've been doing this for years and years. Okay. We're only going to do part A on number 2. We will come back and do part B, okay? What does this tell us to do, this negative 2? Where are we going to put it? With x or 4x. So I'm going to rewrite my function, 3x minus 7. Instead of x, it says use negative 2. And like I said, please put it in parentheses. And then in your calculator, type it the exact way that I wrote it. So 3 parentheses negative 2 minus 7. and you get 13. Everybody okay? Doing okay? Same thing, we're only going to do part A for this one. We're going to write our function 11 minus 4x. And what are we plugging in for x? On number 3? You were just on the bottom one. The 5. Again, put it in your calculator. And we get -9. Don't feel bad about using your calculator right now. We'll come back to part B on this one as well. But let's just look at part A. Look at the difference though. Our new function has a square, x squared minus 2x. This is where if you don't do it the way I tell you to, you're going to get it wrong. Okay, you're going to get it wrong. And I'll show you why you'll get it wrong in just a minute, okay? So when we have x, we want to put in parentheses, -2, the square will go on the outside. So whatever that number is, put it in parentheses and then write everything else. -2, we have a second x, so we got to plug in -2 again. So anywhere you see an x, this is these two problems like 4 and 5 where you have multiple x's are the ones that you miss most on the test, okay? Make sure you plug it in for both. Put it in like you see it. Parentheses, -2 squared minus 2 times -2 gives us 8. That's it. Use that calculator, but be smart, use parentheses. Now, here's what happens if you don't use parentheses. If I just do -2 squared minus 2 times -2, what did I get? Is that the right answer? No. The reason why is this right here. -2 squared, the way they do that is they'll do exponents first, parentheses, you guys know PEMDAS or please excuse my dear Aunt Sally. Okay, so it'll do exponents first, so that means it does 2 squared or 4, and then it puts the negative on it. But we know when we multiply a negative times a negative, we should get a positive. So you have to put it in parentheses to get that positive number, okay? So always use those parentheses, always use them. Look at your next one. There's 2 numbers on this. We're going to do each one. So we're going to start with the first one, x squared plus 3x minus 4, and it says to plug in -4 for all of your x's. Use parentheses, -4 squared plus 3 times -4 for that x as well, and then -4. Literally type it in your calculator. I do not care how much you use your calculator at this point. We get 0. You're going to rewrite the function again. We're going to do this one. But this time we're plugging in what? 2. So 2 squared plus 3 times 2 minus 4. 2 squared plus 3 times 2 minus 4 gives us 6. All right, we're going to go up to number 4B. 4B. You will see these on your final exam. Okay, we will do them throughout the unit, but you will see them on your final exam. What this says is write the function and then plug in 1. So the first thing you do is write the function, plug in 1, and then what does it say on the end? Add 4. 3 more, y'all. We're almost done. So again, write the function, plug in 1, add 4. We'll do multiple ones of these throughout the year, so don't stress too much. There's not, I don't think there's one like this There might be one like this on your test, but we reviewed right before and it was exactly the same, okay? All right, so our function is x squared minus 2x. So we wrote the function. We're going to plug in 1 because that's what it told us to do. And then we're going to add 4. So I just put the plus 4 on the end. Now we just put it in our calculator. So we do 1 squared minus 2 times 1 plus 4 gives us 3. That's it. Okay. So finish the function, add 4. 2 more. I'm going to start with B on number 2. I know I'm skipping everywhere, but B number 2 is where I'm going because it's only got 1 letter. So this says, write the function, and I'm just putting an abbreviation, FCTN is function. Write the function. And then if this one told us to replace x with -2, this one tells us replace x with y. Okay, so just like the other one, we're going to put y in for x. So here was our original function, but then we're going to replace x with y. It's kind of weird. It's just making a new variable. It's the same thing though. So now instead of 3x minus 7, we're going to have 3y minus 7. And that's all you do. So just change x to y. So this one says change x to 2y. And then you do have to simplify. So that's the weird part about it. So 11 minus 4, change x to 2y. What is 4 times 2y? What's 4 times 2? 8 and y. That's it. Okay. None of those are on your test, so we don't really do those. So don't stress out about having to do that, okay? All right. The ones that you need to focus on are the ones that are numbers. So that's why we didn't put very many of those on there. But I did want to go over them so you didn't think that I was just cheating you out of your education. That makes sense. Is everybody good? All right, so let's review what we learned. 3 ways to write. Remember, a table is an XY chart. 2, 6, 3, 4, it doesn't matter what you have there. We learned about a mapping. That's where you have X and Y's and arrows. You know what a graph is. We learned 3 ways to determine a function. The biggest thing is we don't need repeat x's. No repeat x's. And then we evaluated, so plugging in, okay? Any questions about these notes? I think we did an EDA assignment today as well. So you guys will go on there and finish your function assignment. If you have any missing work, you also need to get that done. So this function assignment may not take you very long at all, but then make sure that you go back and do any missing work that you have, okay? Any questions in here? Zoomers, hang out with me for just a minute. I'm going to stop sharing, stop recording.